Circular track racing is an area where you need some pre-derived results to be able to solve your typical circular track questions within a reasonable amount of time. Uh, the fundamentals are very simple. You are going to use relative speed concept. You're going to use, whatever they're asking you to find. First time that two people, a person crosses another person, the first time that they're going to be at opposite ends of the track. These are all, you need conditions uh, relating to the circle, right? You need to understand what to frame to get to your solution, plus some ideas of relative speed. The fundamentals are very simple, but you can build a lot of results on top of this. And if you have questions based on these results, solving from scratch might not be a very smart approach here, because it's going to take a little bit more time. So we are going to pre-derive these results, and we're going to invoke them while we do the questions. Now let's just look at a simple example. uh, there is no question at the end of this example, there's just a random example. Let's just look at what is happening as time goes by. I have two people, A and B, who are starting from the same point on the track. They start running simultaneously in the same direction. Let's say they have speeds of 4:1. I'm not giving you their actual speed. Now, in a question, they might give you the speed of the person as well as the length of the track, or they might give you the lap time. If you're given these two, you can obviously find the lap time. From the lap time, you might not necessarily be able to find the speed and the length of the track. Doesn't matter. They'll usually give you the information required to answer the question that they're asking. So I'm not giving any of this. I'm just giving a speed ratio 4:1. Let's see what happens. So A is gonna run fast, B is gonna run relatively slowly. By the time that B does 1/4, A would have done one full circle, right? And a little while later, A is gonna catch up to B. A is gonna lap B basically. B is still on his first round, A is on his second round, and A is coming from behind and overtaking B again. Uh, this is typically what they ask you to find. First time that they meet, fifth time that they meet, 20th time that they meet, doesn't matter. You want to understand what to frame for. So I'm just going to remove this. You want to look at it this way: the speeds are in the ratio 4:1, so the distances traveled in the same amount of time would also be in the ratio 4:1, and I'm going to take them as 4x and 1x. And what is the condition for the first meeting? This is what you need to understand. What condition am I framing for? The condition for the first meeting is that A has run ahead of B, come back and is beating B again. So notice that A has run exactly one round more than B. It's going to be a little further, but notice that A is run one round more than B, and that's basically your condition. The difference in the distance is one round is the condition for the first meeting. This is basically the first principle for this area. This is all you need to derive everything else, and it's essentially that you know how to write this correctly, because after all the questions that you practice, they'll come up with something else. What is the fifth time that there are the opposite points on the track? Unless you know how to write the starting equation, no result is going to help you. So that's how it is. Delta distance is equal to one round, first meeting, condition for the first meeting. So how do you solve this beyond this point? 4x minus 1x is equal to one round, 3x is one round, which means x is equal to 1/3 of a round. That means the slow person is doing, B is doing 1/3 of a round, A is doing 4x, which turns out to be 1 and 1/3 of a round, exactly one round more. So this is the condition for the first meeting. B is done 1/3, A is done 1 and 1/3. So if this were a clock, you would know that this is the 4 o'clock position, correct? Now once you have this, you can extrapolate from here. You don't have to solve for the second meeting. You can simply say clearly it's going to happen after another 1/3 of the track, because B is going to do this and A is going to do basically this. So as soon as you have the first meeting, from there you can just say, you know, another this much distance, next meeting, another one more meeting. So it's about finding the first meeting, and I will call the starting point as 0 and the first meeting point is 1. Once you get the pattern 0, 1, 2, 3, 4, 5, 6. So if you want the uh, let's say the position of the 50th meeting, you'll simply say 50 by 3 gives you a remainder of 2. So it's going to be at the same point as the second meeting, and that's it. Now you should take one more example like this, with some other ratio. Instead of 4:1, try 3:1 or 7:3 and so on, and you will see a pattern. It's basically, you had a speed ratio of 4:1, right? 4:1 gives you directly 4 minus 1, 3 meeting points on the track. As you can see, there are the 12 o'clock, 4 o'clock and 8 o'clock position. These 3 meeting points will be equally spaced on the circumference, and you'll also see that the last of those meeting points is at the start, at the place that they started running. This much, we've just derived this. You can check it out with another example if you want, or we can take one more. This is basically something you can directly get just by taking the fraction and subtracting the terms. Now when I say that, you have to be very careful with something like this. If I give you 8:2, one guy is running at 8 meters per second, the other guy is just jogging along at 2 meters per second, you shouldn't say 8 minus 2, 6 meeting points. You have to simplify that ratio to co-prime numbers and then subtract. 4:1, so that's 4 minus 1, 3 meeting points. They're going to be equally spaced, and the last of those meeting points, the third meeting point, is going to be at the start itself. Now we have to build a lot more on this. This is just the starting, but we'll continue that in the next video.